Next, after the product rule, product is when two functions are multiplied. Now we have the quotient rule. This is if we have a function that consists of something divided. This is the dividing two functions. So we have a function divided by a function. Quotient rule. Well, the product rule is first times the derivative of the second plus the second times the derivative of the first. The quotient rule has a similar structure. If you actually watched the video with the proof of the product rule, you saw how that proof worked out. The proof of the quotient rule is similar. It's a little more involved because it's quotient, but it's a very similar structure. The quotient rule is this. So if we have, I'll write it out here. Suppose we want the derivative of f of x divided by g of x. All right? So we have function divided by function. In this particular case, this would be f, this would be g in this case. All right? So we have two functions divide by. It is not, I had the same Calculus 3 student that evidently never learn the product rule, didn't learn the quotient rule either. I have students in Calc 3 not doing the quotient rule correctly. They have a rough go in Calc 3. They have a rough go in Calc 2, and my guess is he probably should have had a much rougher go in Calc 1. So you need to learn the quotient rule. You need to know the quotient rule. All right, the quotient rule is this. It seems like the quotient rule is one of those rules that it seems like the teacher's just making it up, just to make it difficult. It's not. This is the way things actually work out. It is denominator. So we have numerator, denominator, numerator, denominator. It is denominator, and you should recognize now, copy, paste. It's denominator times the derivative of the numerator minus, notice the product rule, product is plus. Division, quotient, is minus. It kind of associates together. Turns out it doesn't have to be that way, but that's the way it works. If you're multiplying the functions, it's plus. If you're dividing the functions, it's minus. This sign right here, if I had a dime for every time a student messed up that, I'd have probably, wouldn't have a lot. I had, probably a couple $100. It happens enough. Students mess this sign up more than anything else. It's the first times denominator times the derivative of the numerator minus numerator, copy paste, times the derivative of the denominator all over the denominator. I'll use parentheses. All over the denominator squared. Denominator times the derivative of the numerator minus numerator times derivative of denominator all over denominator squared. Denominator times derivative of the numerator minus numerator times derivative of denominator all over denominator squared. That is a mouthful by anybody's standards. I'm sure if you go on Google and Google memory device for quotient rule, you'll probably get hundreds, if not thousands of hits. I'm sure that there are all sorts of memory devices. I can give you a couple of the students have told me in the past. If they help you, that's wonderful. Some students, they'll do denominator times derivative of the numerator minus numerator times derivative of the denominator all over denominator squared. So that's their little memory device. I've had students do this. I'm going to say this because a student did this in the past. He said this. He says, I've never screwed this up. And I said, okay, if it works. It's stupid. I'll give you that. It's a little goofy. But here it is. If the numerator is high and the denominator is low, high and low, low and high, and then the derivative is the d. Remember, d something is the derivative of something. So this is low d high, so low d high, and then minus high d low, low d high d low, low d high d low. And then I'm telling you this because a student told me this once, not because it's cool. This is stupid. I'm going to tell you it's stupid. Warning, spoiler alert, this is stupid. But here it is. Low d high d low, square the bottom, off you go. If that helps you, wonderful. To me, I just learned the quotient rule. It's denominator times derivative of the numerator minus numerator times derivative of denominator all over denominator squared. There's a something, did Terry dive on the night man? No, something. However you want to learn it. denominator times the derivative of the numerator minus numerator times the derivative of denominator all over denominator squared. There you go. So in our case, denominator times the derivative of the numerator minus numerator times the derivative of denominator all over denominator squared. And just like with the product rule, you need to copy and paste. If you did not copy and paste, it's wrong. It's got to happen somewhere. In fact, it's got to happen twice. In fact, it's got to happen 3 times. So this is denominator, copy paste, denominator. Since there's more than one term, these parentheses are actually needed, not just advised, they're needed. Denominator times derivative of the numerator. Derivative, as if this is the only thing written on the board, the derivative of that is 6. Minus numerator, copy, paste, copy, paste. You see how the copy, paste helps? It helps you kind of keep you along the structure here. Denominator times derivative of the numerator minus numerator, copy, paste, times derivative of denominator, as if that's the only thing written up here on the board. 3x squared minus 8x. 3x squared minus 8x all over denominator, copy, paste, squared. Low d high minus high d low. Denominator times derivative of the numerator minus numerator times derivative of the denominator all over denominator squared. And so you can practice this till you're blue in the mouth, and that's what you probably ought to do. That's what the quotient rule is. Let's just do another little random example here. Suppose g of x is sine of x plus x all over x plus 1. There we go. So I want to find the derivative of that. So that's bump, 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 minus bump, 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 all over denominator squared. So that's denominator times derivative of the numerator minus numerator, and I can't even read that. Numerator times the derivative of the denominator all over the denominator squared. If all you're asked to do is find the derivative, you do not need to simplify it. I just assume you didn't. So, quotient rule, there you go. Now, the quotient rule gives rise to a couple special little concerns here that really do come in handy. Suppose f of x is x to the negative 5. Now, really what that means is the function is, we know what that means, that's 1 over x to the 5th. So just in case we didn't know what that derivative was, we're going to show that the power rule actually works here as well, because officially we've only done the power rule for natural numbers. Now what if this is a negative exponent? Well, we know that these are equal, and so this tells us that the derivative here is the quotient rule. All right, so that's denominator times the derivative of the numerator, but the numerator is a constant. The derivative of a constant is 0. Denominator times the derivative of the numerator minus numerator, copy, paste, times the derivative of the denominator all over the denominator squared. This is x to the 5th quantity squared. Now, this time, because this is a special case, let's simplify this. See what happens when you simplify this. First off, this falls out. 0 times that falls out. So we're left with negative 5x to the 4th divided by, remember, a power to a power you multiply. This is x to the 10th. Now what is that? That's negative 5. And then when you divide the bases, subtract the exponents. So that's negative 5 over x to the 6th over x to the 6th. And we can rewrite that. That's negative 5x to the 6th. So that shows us why the power rule really does work. Now, you don't need to do that every time. You don't need to do that every time. But this is just showing you that, yes, the power rule does work even if this is a negative exponent. So yes, you may simply, because the quotient rule is carrying the water for you, you may simply use the quotient rule, the power rule here. So this says is that the derivative is ordinary power rule. It's negative 5x to the negative 4, and simplify that if you want, negative 6. Right, subtract 1 from the exponent. And so this is negative 5 over x to the 6, if you like. Negative 5x to the negative 6 is just fine by me. All right? So the quotient rule says that's why, yes, we may use the power rule with negative exponents. We may use the power rule with negative exponents. And as it turns out, we won't go through the proof of this, you may use the power rule with decimal exponents as well. Now, the next piece, we'll go through some other examples of the quotient rule. So one more quotient rule. Suppose f of x is, let's just pick something out of the blue sky. Let's do a sine of x over x minus x squared. Just for one more practice here, let's find the derivative. That is denominator times derivative of the numerator minus numerator times derivative of denominator all over denominator squared. Denominator copy paste times derivative of the numerator minus numerator copy paste times derivative of denominator all over denominator squared. And if all you're asked to do is to compute the derivative, just let it sit. Don't bother trying to pick with it. If you need to simplify it, I'll make you simplify it. But if all I say is compute the derivative, especially if I say specifically do not simplify, just let it sit. So there it is. There's the quotient rule.